So good evening to those in India and welcome to all people from all around the world for this webinar as a part of the Sustainability Seminar Series organized by the Dr. Kiran C. Patel Center for Sustainable Development at Indian Institute of Technology, Gandhinagar. My name is Jaychandar Swaminathan. I'll be the host for today's webinar. I am a faculty member in the Mechanical Engineering Department working on energy efficiency of desalination technologies. Today we have two speakers with us to talk about the Programa Água Doce, or the freshwater program of the Brazilian federal government. So the program is focused on providing drinking water to semi-arid rural communities through desalination in Brazil. The Kiran C. Patel Center for Sustainable Development at IIT Gandhinagar is an interdisciplinary center that has faculty members from all over the institute working on sustainability. So we have around 5 focus areas as of now, including water, energy, climate change, waste management, as well as ecosystems. As part of this series, it's my pleasure to welcome you to this particular webinar. So I have the agenda briefly listed on the right-hand side of your screen. So we'll first have Henrique Veiga, who will be the main speaker, followed by a presentation by Emilio Gabbrielli, and then we'll have time for some question answers from the attendees. Okay. Let me just introduce the main speaker. I'll also share a little bit about my personal experience with this program and how I ended up inviting these speakers for the event. Around 3 years ago, exactly the same time, October 2017, there was a conference in Sao Paulo, the International Desalination Association World Congress. During this conference, the Água Doce program that we'll hear about today was awarded one of the prizes, and I actually had the opportunity to visit one of their sites to see in action the desalination plant supplying water to a very remote community. It was a very interesting experience because during my trip to Brazil, I also had the chance to camp in the Amazon rainforest, to do which I had to cross a couple of mighty rivers. But at the same time, Brazil being a very large country similar to India has all kinds of environmental conditions. So we took a road trip and we were able to see the geography changing as we moved along to more and more dry regions. Also, we reached a very remote community, in which case the water supply was an issue and it was being solved through the desalination plant. So it's a very good experience. Thank you, Emilio, for organizing that trip during the conference. And that is how I learned about this. Henrique also gave a talk at that conference. So I'm really looking forward to listen to further details on the program and how it's evolved since then. So Henrique Veiga is an experienced environmental analyst with a deep knowledge of water resource management and watershed restoration. As a staff member of the Brazilian federal government since 2008, he develops plan and management activities and technical support on the freshwater program, or Programa Água Doce, which provides access to clean water in remote localities in Brazil's semi-arid region. Henrique Veiga holds a bachelor's degree in biological sciences from the University of Brasilia and a master's degree in environmental resource policy from the George Washington University. He has a graduate diploma in environmental management and public policy from the Center for Sustainable Development at the University of Brasilia, CBS, and a certificate in climate change proficiency from the Center for International Postgraduate Studies of Environmental Management in Dresden, Germany, the Technische Universität in Dresden. So with that brief introduction, I'll invite Henrique to please start sharing your screen and go ahead with the webinar. Thanks.
Hello, everyone. It's such a pleasure to participate in this seminar and share a little bit of the experience of the Água Doce program, the freshwater program. First of all, on behalf of the Ministry of Regional Development, I would like to thank Dr. Jay, Dr. Emilio, and all the organizers for this opportunity. I will firstly show a short video from the National Secretary, and then a short video about the program, okay?
Quero cumprimentar a todos que participam do seminário de sustentabilidade tenho a honra de vir aqui apresentar a vocês o Programa Água Doce, que é um programa desenvolvido pelo Ministério do Desenvolvimento Regional, um programa que tem uma atenção especial do ministro Rogério Marinho. O ministro Rogério Marinho nos pediu para que a Secretaria de Segurança Hídrica tivesse o projeto Água Doce como um projeto prioritário. É um projeto que transforma a água salobra de comunidades carentes em água potável, em água de boa qualidade, trazendo dignidade a essas pessoas. O governo federal já investiu mais de 287 milhões nesses programas, vai investir mais 39 milhões esse ano. Então, nós já entregamos 840 sistemas, né, dentre 1.200 que serão entregues. Isso é um programa, isso demonstra a atitude do governo Bolsonaro. O presidente Bolsonaro se preocupa com a dignidade das pessoas, se preocupa com o mais carente. Basta olhar o investimento que temos. Todos os estados do Nordeste estão contemplados com esses investimentos para o Água Doce. O Água Doce é um programa que ele tem o carimbo da sustentabilidade, né? Porque além do programa em si, aí nós temos alguns pilotos que tanto usamos a água, o rejeito para plantar a triplex, que é uma planta que é dada ao gado, que estimula a agricultura familiar. Também podemos, através da água salobra, temos pilotos através de parceiros, onde a gente faz a produção de tilápias. Então também damos sustentabilidade. Além do programa fornecer uma água limpa, uma água potável, ele também tem a possibilidade de fornecer renda às pessoas que estão sendo utilizadas daquele sistema. Além do mais, tem uma coisa muito boa nisso. As comunidades elas passam a fazer a gestão desse programa, o que é importante, porque quando a comunidade faz a gestão do programa, ela valoriza a água que tem. Então, quando eu falo com um entusiasmo desse programa. Inclusive, quero parabenizar aqui em público, quero parabenizar a minha equipe, a equipe da diretoria do DRHB, onde são pessoas que vestem a camisa do programa, que levam o programa às comunidades, que vão às comunidades, né, tratar. Quero agradecer aos estados que compraram a ideia do Água Doce, aos municípios que estão sendo atendidos. Então, é um programa que ele nasce, né, é um programa do governo federal, mas que ele traz junto de si os estados e os municípios, mostrando a integração desses entes, mostrando o quanto o povo sertanejo, o povo nordestino é importante para o governo brasileiro. Então, eu quero dizer a todos que fico lisonjeado em participar desse seminário, em ter aberto a palavra a mim. Agradeço a vocês e desejo a todos que tenham um seminário profícuo, um seminário com boas ideias e um seminário que possa ajudar ainda mais o nosso povo nordestino, o nosso povo brasileiro. Muito obrigado.
A gente tinha um poço aí, só que a água não era de qualidade. A água, como a gente chama aqui na região, de salobra.
Nem se compara assim. A gente já vê um sabor bem melhor. A gente sente a pureza na água.
O Relatório Mundial das Nações Unidas sobre o Desenvolvimento dos Recursos Hídricos prevê que as reservas de água do mundo podem reduzir 40% até 2030 e que a demanda por água aumente 50% até 2050. Dispor de água doce é fundamental para a segurança alimentar e para a saúde humana, contribuindo significativamente para melhorias do bem-estar social. É nesse cenário que surge o Programa Água Doce, uma ação do governo federal coordenada pelo Ministério do Desenvolvimento Regional, que visa o estabelecimento de uma política pública permanente de acesso à água de boa qualidade para o consumo humano. O programa incorpora cuidados técnicos, ambientais e sociais na implantação, recuperação e gestão de sistemas de dessalinização, prioritariamente em comunidades rurais, contribuindo para a segurança hídrica no semiárido brasileiro.
A gente não tinha um sistema que a gente carregava da mata, transportava de longe, e hoje melhorou por isso, né? Temos na cidade, né, onde nós abastecemos aí as escolas, a instituição todinha do município é abastecida com água do Programa Água Doce.
É um grande desafio possibilitar o acesso à água de qualidade para comunidades difusas em uma extensão territorial de mais de 1 milhão de quilômetros quadrados, que corresponde a 13% do território brasileiro e abrange 10 estados: Maranhão, Piauí, Ceará, Rio Grande do Norte, Paraíba, Pernambuco, Alagoas, Sergipe, Bahia e Minas Gerais. O semiárido possui cerca de 22 milhões de pessoas, sendo que 9 milhões na zona rural, população prioritária para o Programa Água Doce. Nessa região, caracterizada pela escassez hídrica, onde as águas subterrâneas são uma das poucas fontes disponíveis, além das baixas vazões, mais de 70% dos poços apresentam água salina ou salobra, tornando-as impróprias para o consumo humano. O semiárido é uma das regiões que serão mais afetadas pelas mudanças do clima, já que os eventos climáticos extremos se apresentam cada vez mais frequentes e mais intensos. O programa utiliza a tecnologia de dessalinização por osmose inversa, que transforma água salobra em água doce para o consumo humano. Quando as condições técnicas e ambientais permitem, a água concentrada em sais pode ser aproveitada na criação de peixes e na produção de cultivos apropriados ao semiárido. O Programa Água Doce adota um modelo de gestão compartilhada, na qual o governo federal, estados, municípios e as comunidades locais assumem as suas responsabilidades para o bom funcionamento dos sistemas de dessalinização.
O programa sempre sugere um acordo, mas cada um pode modificar seu acordo de acordo que não fuja dos padrões que o programa exige. Porque cada comunidade conhece a sua comunidade. Cada grupo gestor conhece como opera a sua comunidade.
Foram firmados convênios com 10 estados, com investimentos na ordem de 260 milhões de reais para a implantação de 1.200 sistemas. Até o momento, 3.677 localidades foram diagnosticadas nos 300 municípios mais críticos do semiárido. Cerca de 800 sistemas estão funcionando com seus acordos de gestão formalizados. Já há potencial para fornecimento de 3,2 milhões de litros de água doce diariamente à população. Cerca de 2.400 operadores foram capacitados e aproximadamente 320 mil pessoas atendidas com água de qualidade para o consumo humano.
Eu acho assim que foi um dos melhores programas assim em relação ao que o governo federal investe em comunidades que a gente adquiriu. Muitos disseram que isso não ia funcionar porque em outras comunidades já não ia ter sido abandonado, mas aí a gente enfrentou e até hoje, graças a Deus, vem funcionando.
Agora o desafio é avançar no caminho da sustentabilidade hídrica, alimentar e energética, ampliando o uso de energia solar fotovoltaica e incorporando boas práticas de conservação de solo e água. Com isso, o Programa Água Doce busca melhorar as condições de vida das populações locais, renovando esperanças, preservando o meio ambiente e respeitando a cultura das comunidades.
Eu agradeço muito a Deus mandar o inverno e na minha cisterna pega água, mas eu sou mais a do poço. Satisfeita com ela porque eu sei que é uma água limpa, é uma água tratada.
É um direito de todo ser humano, é a água, e água pura, água boa. Então, se esse é o meio que a gente tem, então vamos correr atrás e vamos abraçar a causa.
Porque água é um bem público e o acesso à água de qualidade é um direito de todos.
So the idea here is to share a bit of the results, the challenge, and some of the perspectives around the freshwater program. I think it's important to highlight that this program was carefully designed by a multidisciplinary team from the social science, engineers, environmental science, and taking into consideration two main issues that we identified when we were designing the program. One of the main challenges that the government faced before the program was the lack of the engagement of the society, the communities. And the other problem was the direct disposal of the brine in the soil. So we generate some environmental problems in these communities. So all this team got together and established a methodology in how to implement this program. I think this is one of the main things that worked in the program, because all the communities are engaged, the municipalities and the state government are engaged, and we have this methodology that take this water that was a marginal water that was disposed improperly to be usable. I mean, to use this brine to cattle feeding, to irrigate plants and feed for fish farming. So let's start. And another thing that I want to share is that the program is not about just installing desalination plants. I think it's more than that. We used to say that all the problems and challenge work when we finish the installation of the plants, because the great challenge is how to keep these systems functional, delivering water. So and the engagement of the communities are crucial for this process. So to have an idea about the region that we are working.
We don't see the presentation. Can you just restart the sharing?
You can't see?
No, so the screen is blank. Maybe if you restart.
Okay, let's do it again. Can you see now?
No.
Nope. Strange. Share the screen. And now?
No, Henrique, do you want me to pull it up on my computer?
Maybe it will be better.
Okay, I'm doing it.
I'm doing exactly what I did before we started, but
yeah.
I don't know what's happening.
Okay, I have it up. Just give us 1 second, everybody. Henrique, you can stop sharing. I'll just share it from my computer. Yeah. So is it visible to you, Henrique?
Oh. Yes, perfect.
Just tell me when I should go to the next slide, okay?
Okay, thank you, Jai. So to have an idea about the region that we are working, it's an area that is more than 1 million square kilometers. That is around the size of France and Spain together. So it's a huge, huge area, 30% of Brazil's territory. We are talking about 26 million people that live in the semi-arid region, and almost 10 million still live in the rural area. In the rest of Brazil, we have already 80% living in urban areas, but in the semi-arid region, we still have many people living in these isolated communities in that situation that you could see in the video. About the precipitation, we have annual average precipitation of 800 millimeters per year, which is quite a lot for a semi-arid, but we have very, very high evaporation rates. That is almost double the quantity. It's around 1,300 millimeters per year. So we have these very high evaporation rates. because all that, and because the geological conditions, we have low superficial water and low hydrogeological potential. I will show in the next slide a little bit about this. And this region is characterized with a very low human development index and low rates of access, high poverty rates, and is one of the regions that will mostly be affected by climate change, with more intense and severe and more frequent droughts. So that's why the Água Doce program is also an adaptation measure. So it's contributing with the water security in a very uncertain and scenario. So let's move to the next one. So here we have a figure showing the hydrogeological potential of the region. In the left side, we have a part of Brazil where the northeast region is. We have these fractured rocks along all the area, this pink area in the left. And in these fractured rocks, we have, as we know, we have very shallow soils, and all the water wells are done in these rocks. And when we find some fractures, we have a productive well. However, the production rate is very, very low, around 1,000 liters per hour, the average of the production of this well. And when we find water in this well, usually they are brackish or saline. This is because the geological conditions and also the climate conditions in the area, because of the high evaporation rates and all these characteristics of the rocks. So this water becomes salty or hard. So we can move forward, please. So what is the objective of the program? The program, as I said, is more than a process, is more than a construction program. It's focused on a process. So it aims to establish a permanent public policy of water access for human consumption, considering technical, environmental, and social precaution in the construction and management of this desalination system. This program is just possible because we have a huge net of institutions that is working together to this objective. Here I listed a few of these institutions. I will highlight the Water Agency, the Brazilian Water Agency, the Brazilian Geological Survey, the Brazilian Agricultural Research Company, some university, and we also have an international support from IDA and the direct involvement of the state government and all municipal government. So now we have more than 1,000 institutions working together to ensure water for these people. We can move forward, please. So the program is based on some principles. I would say that community empowerment is one of the key ones. So that's why we ensure that these systems will work properly, delivering water as we want. Another key aspect is the co-management approach, where the federal government, state government, municipal government, and the local community have their responsibilities. The program is also focused on the environmental sustainability. So how can we minimize the impacts, the environmental impacts of the brine disposal, and also think about ways of using this water in a sustainable way. And other thing that it's important to highlight is a permanent technical capacity building. We are always yearly doing this capacity building events, not only for the state, but also, and most important, for the community. So all the operators, the plant operators are participating in this capacity building process, and many other institutions in the local level and the state level. This is a very key for the success of the program. Next, please. So as you may know, the technology uses the reverse osmosis desalination. This is a very powerful technology, and one of the things that is very good is that we can construct a very small system. It's a modular system, so we can install a proper equipment for the proper water and the proper production and the proper demand of the community. So we can have very small systems or a bigger one. And as we can see here, it's a very potent technology that take out all this virus, bacteria, and we can set the equipment to have a very good quality water with some salt inside. That is very important. So we don't have a water that is it's totally absent of salt. So it's a very potent and important technology. Next, please. So we have two main setups for the program. The basic one is this one that we can see here. So we have the water source that it comes from the well, a raw water reservoir. So in each community, we assess all the previous demand for the water. So sometimes, depending on this quality, we can use this raw water for other uses than for drinking. So it's very important to keep a tank, a reservoir of raw water. We have a desalination system itself inside this little building. And after the process, we generate two waters, okay? One that is the potable waters that pass through the membranes, that is distributed through fountains to the community. And we have another reservoir for the concentrate. In some cases, we can use this concentrate, for example, for feeding the cattle and the livestock. And in all these systems, we have two tanks or one tank, depending on the production rate, to dispose this brine for evaporation. So we mitigate the environmental problems regarding the disposal. Next, please. And we also have an integrated production system that was developed by Embrapa, that is the agricultural research company, the national research company, that uses this brine for fish farming. In this case, we use tilapia fish, and this water from the fish tank is then used for irrigate some halophytes crops. For example, the Atriplex numularia, that is a very good plant for cattle feeding for the livestock. So in this case, we have a circular economy, I would say, a circular process where we have the water for the people, the drinking water for the people, but also we are optimizing the use of the brine for increasing the food security and increasing the livelihood of these communities. One of the things that we are challenged is how to scale up these productive systems. This whole system demands a high quantity of water, at least 5,000 liters per hour. We have to have a well that has this production rate. However, as I said before, it's very, very, very difficult to find a well with this 5,000 liters per hour of production. So that's one of the reasons that we are facing challenges regarding the scale up of this system. And also another very key component, the bottleneck, is also the depth of the soil. We need to have at least 1 meter depth, the soil profile. And it's very, very hard to find 1 meter depth of the soil, especially to ensure the sustainability of the production of the Atriplex numularia. So now we have some research that is done by the Embrapa that's tried to make this system more flexible. How we can use different setups that demand less water, or some hydroponics, some other things that we can do in the system to scale up this idea. Next, please. So another thing that I think is worth mentioning is about the prioritization criteria. As I said, it's a very huge area, so, and we don't have all the money we need. So we think about, if we need to start somewhere, where is the worst, where is the most critical locality? So we combine the different variables to highlight the importance of some areas. So we use the precipitation, the human development index, infant mortality, poverty haze rates, and also the brackish groundwater occurrence. We combine all these variables, and we finally had a rank of the most, from the most critical municipality to the least critical. And in each state, they did the same. They use this index to make the ranking for their municipalities, and they are starting from the most critical one to the less critical one. I think this is a very important idea to optimize the investment. So we are attending first the one that most need. Next, please. About the institutional arrangement, I think it's very important. We have a very solid arrangement. Firstly, in a national level, where the Ministry of Regional Development is the coordinator, but as I said, we have many other federal level institutions that is involved, and we have 4 different technical components: the social mobilization that looks for the engagement of the community, the shared agreement, and so on. We have this environmental sustainability coordination that looks for all the environmental conditions, the best use of this brine, and so on. The very technical coordination, that desalination do all the tasks, the technical basis for the proper installation of these desalination plants, and also a productive system coordination that looks for how to use this brine in a productive system. We have exactly the same structure in the state levels. For each state of the Northeast, we have a state coordination, all these 4 components. And the most important, at the local level, we have a local management group that all the municipalities, the municipal institution, and also the communities are organized and engaged to the proper functioning of these systems. Next, please. So about the methodology and costs, we have 3 main steps. The first one is the community assessment. For each community, we go there and make the social environmental conditions, what they are producing, how many people are there, how is the demand, how is the production rate of this well, all the water and soil analysis, and finally we have the plant blueprints. And the second step is the construction or the restoration, recovery of the plant. That, of course, it's where we install the desalination equipment and also the plant construction. And the last step, that it's a permanent one, I would say, it's the monitoring and maintenance. For each of these contracts that we have with the states, we are planning 4 visits a year, so we can keep these plants functioning properly. So it's a very, very key step for keeping these systems working. Next, please. About the costs, each of these equipments, these plants costs around $50,000 in the current rate, so it's around 278,000 Brazilian reais, and the costs are divided in this step. So we have around $2,000 for the assessment. The plant construction is around $30,000. The equipment itself, the desalinator, it's around 8,000. The monitoring and maintenance about 3,500 per year, 4 visits a year. And we have also a management support for the state. In this management support, we have all the capacity building events, the fiscalization, all these costs are inside this value here. And we also have the opportunity to install some photovoltaic system that will add another around $15,000 each plant. Next, please, Jai. About the shared management approach, we have basically 3 main things that we need to look: the operation, the maintenance, and the water quality monitoring, all the water analysis. So at the local level, the management group is responsible for the operation and for paying the operator, the energy costs, and they are also they can also make small and simple repairs, because in each, as I said, in each plant we do this capacity building. Many operators are formed in this community, so they are able to properly operate these systems and also promote some repairs if it's the case. And it's important to highlight that in each community, the own community establish a small amount that is paid per family per week, for example, and they manage this fund. It's a local fund, and for paying the energy costs, for paying the operator, and for doing these small and simple repairs. So the local community manage this local fund for this purpose. And at the state level, with the support of the federal government, we have the maintenance and water quality monitor, because it's a more qualified, technically qualified thing. So we have to contract a specialized company to make this chemical cleaning, the substitution of membranes, some adjustments on the system, and also all the water quality monitoring. And we always monitor the 4 waters: the raw water from the well, the permeate, the brine, the fountain, and the permeate, the fountain, and the brine. So we can know how good is this water, and if we can use the brine, for example, for cattle feeding and so on. So it's very important to know exactly the quality of these 4 different waters. And about the operational costs, each plant costs around $9,000 per year to keep functioning, delivering water, good quality water. So it's not expensive at all. I think it's very cheap to ensure water and health for these people. It's very cheap. So we can move forward, please. Now let's go to the results. We have already done almost 4,000 assessments in each of these communities, so we can have an idea here how many. All these blue dots are communities that were assessed. So as I said, we do all this. We ask about all the environmental and social condition of these communities. So this information can be used not only for the program, but for many other federal and state and municipal governments, for other public policies and for other projects. And the communities that are selected, so the next step is to make the blueprint. So we have already done a bit more than 1,000 plant blueprints, and we can move forward, please. About the plant construction, we have done already 840 plants already, with total beneficiaries of around 320,000 people, with the capacity of producing 3.2 million liters per day. And we have already 2,400 operators trained in each of these communities. We used to train more than one in each community. Usually it's 4, 3. So it's important because if the main operator has some problems, I don't know, get sick or whatever, go out to the community, we have another one and another one, so they can keep the plant operational. And the goals by 2022 is to finish this first phase of the program, with the goal to install 1,200 systems with almost 500,000 people having access to water, with a total investment of 6 million people. And now we are planning the second phase of the program, the next 10 years. So we are doing a very hard work in raising funds and trying to find some partners, not only in Brazil, but also abroad, to have the financial and the money to advance for the second phase. Okay, next please. About the perspective, we have 2 main goals. I would say that increase and enhance the knowledge and the application of the biosaline agriculture. So which cultures, which plants can be irrigated with this brine, of course, with the proper the precautions and how to ensure sustainability and mitigate the environmental impacts of this agriculture. So we have a very many reference about this technique. So Embrapa is doing researches and probably in a future, very short future, we'll have other cultures that could be irrigated through this brine. And the other thing that I will highlight is the use of photovoltaic solar energy. We have already one plant in one state that is running through photovoltaic solar energy, but now the idea is to expand the use of this technology for at least 30% of our system. One of the main problems is that since we are talking about very isolated communities, many times the energy in this community is not that reliable and stable. So many times it's go down and go up, go down and go up, and this can have problems in the equipment, and sometimes the communities cannot have the water because for some reason the energy goes off. So the idea is to make it more reliable using this kind of technology. And on the other side, we also will decrease the operational cost. So it's a win-win situation, of course, and that's the idea, to expand the use of this technology in all the systems. Next, please. That's all. I'd like to thank you again. I hope I could keep in time, and I will be here for the next section, the question and answer section. Thank you so much, Dr. Jai, Dr. Emilio. Thank you.
Thank you so much, Henrique. I also want to mention to the audience that you can please use the Q&A feature to ask any of your questions to Henrique. We'll come back to the questions after the presentation by Emilio. Before we go to Emilio, I'll just give you a brief introduction about him. Emilio Gabbrielli has a degree in chemical engineering and a post-degree certificate from Bologna University, Italy. He has 45 years worldwide experience in water, in particular all aspects of desalination and water reuse, and is now operating as an independent consultant. Between 2003 and 2008, he was the CEO of the Global Water Partnership, the IGO, promoting sustainable management of water resources. He has served the IDA, the International Desalination Association, as a director for several terms and as president between 2015 and 2017. He is a member of the International Desalination Association Honorary Council and vice president of the IDA Foundation. He is an honorary global ambassador of the Australian Water Association. Welcome, Emilio, and thanks for giving this talk. I'll just share your presentation and you can get started.
Thank you. Very good. Well, thank you, Jay, and thank you for, in fact, giving me the opportunity to be part of this webinar. I have the privilege of having become familiar with the Água Doce program because at the end of my career, it's one of the most exciting things I have known in desalination. And I'm very pleased to be part of this type of webinars because I believe that the Água Doce is an experience that has got a lot of things that can be copied elsewhere. And I don't have the evidence of other programs which are similar to these ones. It is a program that works against all odds. Probably the reason why I love it so much and admire it so much is that when I heard about it originally, I didn't think that what I was hearing could be right because I didn't think that it could be possible. In fact, if you go to the next slide, please. My start in desalination, as I often say, is a very long time ago in something very similar to the Água Doce in northern Peru in 1974, where most of you would not have been born. I had the privilege, even in that case, to help building a little solar plant in this rural community, very similar to the Água Doce communities. In fact, if you go to the next photo, I got this just from I put the name of the town in Google, and then I got this photograph. So obviously, this is the problem of water in these places. Now, this project I was involved in was in a community which had only brackish water, very polluted, and some students brought us there to see what the big problem was. So we helped, and the community helped building the plant. The government gave some money for building it, and it worked. In fact, when it was built, it was exciting. And in fact, I had enough time to become excited about desalination and decide that that would be something worthwhile to develop my career. But the project itself, unfortunately, was not of Água Doce program and failed miserably because after 1 month, in one night, the whole plant was dismounted and destroyed, and the day after there was only the concrete slab left. Why? Because an enthusiastic part of the community had promoted it, but within the communities, there are a lot of people that were against them. They were not understanding. People had not really been prepared to understand how important the water was, and so it was not the full community that was participating. And one of the critical things for the Água Doce is that when they've done all those assessments that Henrique has talked about, one of the critical ones is that the community has the capacity or the experience to cooperate. If a community is not homogeneous, is not united, even if everybody has got the right to have water, but with the limited resources that the program has, the community, in fact, the Água Doce goes to the community where it will work, because it's useless to put a plant where the community is not ready to take ownership and responsibility of this. So this is really why I came to the Água Doce with skeptical views because of this first experience of mine. Next slide, please. And it was amazing to me that, in fact, in 2015, when we had this desalination conference in Rio de Janeiro, I was living in Brazil, and I was just becoming then the president of the IDA. I already was traveling all around the world. I thought I knew nearly everything about desalination. Well, these very humble and very capable friends of mine of the Água Doce were in Brazil. I didn't have a clue that there was this program because they were all doing these things themselves, and the world simply didn't know about them. It was an amazing situation. And in fact, if you go to the next slide, I was lucky that in that conference, the son of one of the construction people of the little plants of the Água Doce noticed that I was a representative of the Desalination Association. So he mentioned to the organizers or actually to the team of Henrique, that there was this strange man that was actually the international guy of desalination. So why don't you invite him to talk to us when we have one of our meetings? And that is when I went, ready to expecting that in fact I would be disappointed. I expected to find some corrupted institution which was or constructions which would build 60, 70 plants in the middle of the desert, where like if they were pumps, and give them to the community with no support, and the plants would stop immediately from working. And that was not at all the case, and that is why it was so fantastic to find that this was working. And Henrique has mentioned, in fact, that some plants are being recovered. In some of these communities, in fact, there had been some early experiences of putting a desalination plant in this unparticipative way, and in fact, they had not worked. So the mechanisms that the Água Doce was able to develop through their experience at the beginning, science was not there ready for them to find a perfect program, but through trial and error, they realized that the community was really the pillar for this to be successful. So next one. So it was with pleasure that in fact we had this visit at one of the communities that Jay referred to. In fact, you can recognize him with a square shirt with squares there. That's right, there is. And he knew, in fact, the project. I don't know where you are there, Henrique, but you were there somewhere. So anyway, next slide. And so the participation of the community is the pillar of the Água Doce. It's not technical, it's not institution, is just the community participation and ownership. Next one. And then the fact of the operators that Henrique was talking about that come from the community. And if the community manages to have enough resources, in fact, to pay for the operators, they do, as Henrique said. What Henrique didn't say, and sometimes the community doesn't have the money even to pay for the operators, and they work anyway, they operate anyway, because after all it is the water for their families. And it's very, very sad that not only they don't have enough water in that region of Brazil, but they also have wells that produce so little. You've heard how much little water comes out, so you can't even produce more than just the bare minimum. And so the Água Doce produce on the basis that every person of the community has at least 40 liters of potable water per week, and the little infants can have enough water to be bathed in clear water. But unfortunately, you can't do much more than that because there is not enough water. And another good thing of the Água Doce that shows how socially motivated they are. You see all these operators. Now, the Água Doce is talking to education institutions to try to develop a program complementary to their training programs, so that these people get a certificate, so that makes them, in fact, capable of finding additional work as maintenance people beyond the Água Doce. So obviously, it's part of the circular economy. You don't, in fact, if you go to the next one, you don't only try to create fish and everything in a circular economy, but you also try to develop the skills of the people of the community, so they've got more opportunities for being employed. And one of the things that I would like to stress that already Henrique said, the limitation of not all the plants having this reuse of the brine is based on the fact that the wells tend to have such little flow rate that you don't produce enough brine to make it to make the creation of fish possible, and growing the plants that you can feed then to sheep and cattle, because the program would do that all the time if there was enough water. So and therefore, again, this program that was totally unknown to the rest of the world until recently had already worked with a sustainable approach the key problem of desalinating water in inland areas, which is really what you do with the concentrate. And they had found a very, very applicable source. I have spoken about it since I knew it to many people, and you know, for people from Iran and China, that they've been appreciative of this solution, because they have tried to do desalination in remote areas, but they have not thought of what to do about the concentrate. Next one, please. And this effect of the solar energy, obviously that completes the circle. It enables, in fact, the communities to have energy in a reliable way and in an affordable way. And this is the obvious future of the Agua Doce. You know, you've got limitations of resources, so you have to give at least the water to the people. So that's why they're only giving 30% of the solar plants to the plants they do. But that is an intrinsic part of the strength of their planning ahead. And if you go to the next slide, this is this same place 2 years before. The solar panels had been put on the roof. And again, the Agua Doce developed its own know-how. I mean, they develop, they try. So they found that on the roof, it was not easy to maintain. And so they put it down, but also they ran for 2 years without energy accumulation, energy storage. And they found that, yes, the variability was certainly not making things easier. So now they have put back energy storage. But just this to say that the Agua Doce does not try to buy solutions. They try to develop their own ones, which are good for their communities. Next one, please. And don't get frightened. These are all the things that I've already said practically, but these days you can take with the photograph a shot. I don't know if you'll develop, if you give this presentation to people, but I wrote this as a summary really of these important points of the Agua Doce, which I think are a good reference for anybody that is thinking of using it as a framework, as an example for developing something similar. So this is all. Thank you. The next one is just a slide to thank you for listening to me.
So I'd like to take this opportunity to thank both our speakers. I think we've answered all the questions that have come in. Thank you so much, Henrique, for taking the time out. Early morning for you and very late night for Emilio in Australia, but we managed to get it done in a suitable time slot. And I think we all learned a lot, and we hope to stay in touch. All of our audience will also reach out to you with any additional questions. Thank you.
Thank you.
Thank you. Thank you so much, Dr. J. It was a pleasure to represent the Ministry of Regional Development, the Secretary Sergio, the Director Wilson, and also the Coordinator Alexandre Saia. We have a huge team behind the water, the Agua Doce program. It's many people that working hard to do this program a good program. Thank you so much.